3 reasons why this isn't possible.
The snake is just chilling on the wing.
No, it isn't. Reason 1, that's an Airbus A320 and it cruises going 250 meters per second or 560 miles per hour at an elevation of 10 to 11 kilometers above ground. I calculated the air density at 0.38 kilograms per meters cubed. Multiply that by velocity squared and divided by 2 and you get the dynamic pressure at 11,875 newtons per meter squared. The frontal area of the snake facing the wind is its length of 1.5 meters times the diameter of 5 centimeters times the sine of 25 degrees, which is 317 centimeters squared. The snake has a cylindrical shape, meaning it has a drag coefficient of 1.1, and if we multiply this by the dynamic pressure and the frontal area, we get the drag force at 414 newtons. That's the force pushing it off the plane. The force helping keep it on the plane is static friction, which is friction coefficient times the normal force or its weight. The friction coefficient is 0.2 and the snake is about 2 kilograms, meaning its max friction force is just 4 newtons. That's just 1% of the drag force, and it's even barely enough to counteract the sandpaper pulling the boundary layer, which I calculated at 3.6 newtons. Reason 2, Churchill-Bernstein says the heat transfer coefficient on a 5 cm in this flow is about 200 watts per meter squared Kelvin. The surface area of the snake is pi times length times diameter, or 0.24 meters squared. The snake's internal temperature is 30 degrees Celsius and the air temperature is negative 45, meaning the difference is 75, and if you multiply everything, we get the heat transfer rate at 3500 watts. The total energy the snake has is mc delta T, which is 210 kilojoules, meaning the snake will be frozen in less than 1 minute. I'm not done yet. Reason 3, barometric pressure at 11 kilometers is only 22 kilopascals. Oxygen is 21%, so inspired PO2 is 4.7 kilopascals. Plug that into the alveolar gas equation, subtract water vapor and a little CO2, and lung PO2 collapses to 2 kilopascals. Reptiles need about 9 kilopascals to keep normal aerobic metabolism, which means the snake's muscle power fades in seconds and it will be unconscious in under a minute. So by doing some simple math, we know the wind has pushed it off, it's frozen, and it has no oxygen to survive, meaning this video is without a doubt a fake.